Hi guys, welcome to the first lecture. This is R.2, Algebra Essentials. What we're going to cover today is scientific notation, simplifying expressions with exponents, simplifying expressions with radicals, evaluating expressions when you're given a value for the variable, especially expressions with absolute values and radicals. Then we're going to use interval notation to graph inequalities and talk about domain. I should probably get started because that's a lot. All right, so for scientific notation, other topics in the section that we will be bringing back later are translating from English into math, right? So a sentence into symbols, and then finding the domain of rational expressions as I already said. All right, so scientific notation means we have a number a point b times 10 to the power of, that should look more like 10 to the power of y, where y is an exponent. So it's a point b times 10 to the power of y. Good. So when you think about scientific notation, you always have, it is important to note that this a is only between the numbers 1 to 10. So there can only be one digit in front of the decimal. So it's going to be either going to be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay. And then we're going to take that and we're going to multiply it by 10 or 10 to the power of a number, right? So if it was 10 to the power of 2, for example, that means that 10 got bigger, right? 10 became 100. If you take a number, instead of A, B, 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 I'll say, oops, sorry, let's try to clear an eye. 1.2222, or only 3, times 100, right? Because 10 squared is 100. What happens with that 100 is that that decimal point moves over those two zeros. So 10 to the power of 2 is 100. That 100 times the 1.2 becomes 122. A, B, B, point B, right? We moved it over 2. Conversely, when you make that exponent a negative, we move in the other direction. Because 10 to the power of negative 2 is a decimal, right? So that's a smaller number. So that in that case, we're going to move in the other direction. So instead of A point BB becoming A B B point B, it's going to move 2 places in the other direction. It's going to be 0.0 A B B B. And that is the gist of scientific notation. You want to take either a very big number in this case or a very small number in this case and turn it into a single digit with possibly some numbers behind the decimal point. Okay? The exponent is positive if the number is greater than 1, and negative if the number is a small decimal less than 1. Good. The number that the exponent is tells us how many places the decimal point should move. 1.37 times 10 to the 5th is in proper form, while 13.7 times 10 to the 4th is not, because, like we said, this has to be between 1 and 10. Okay, so if that has to be between 1 and 10, 13 is not between 1 and 10, so we're going to move it. Instead of 13.7, that's going to become 1.37. And then I moved it once, so that means I'm multiplying it by 10, right? 1.37 times 10 is 13.7. 13.7 became 1.37 times 10. It's just another way to write 13.7. And then we have that original 10 to the 4th. Okay, now we're going to use the rules of exponents to say what is 10 times 10 to the 4th. We're going to add the exponents. The base is the same, so that becomes 1.37 times 10 to the 5th. Good. All right, so let's practice. 3,127 in scientific notation is going to be, here's the decimal point, right? Here's the decimal point. Here we can see the decimal point. Let's move it. 1, 2, 3. So that becomes 3.127. I stop it when I'm at a single digit between 1 and 10. I moved it 3 places. So we're going to say 10. I made it smaller, so times 10 to the positive 3. Here I'm making it smaller again. 1, 2, 3, 4, 8.6 times 10 to the positive 4th. If you want to pause, try this problem and then restart the video to make sure that we get the same answer. I think that that's an excellent idea. You should do that. Here we have a small number, so that means it's going to become a single digit. That means my exponent is going to be a negative exponent, 10 to the negative something, because this is a small number. 1, 2, 3, 4. I'm going to stop when I get to my first number after the decimal point, 3.13 times 10 to the, how many places did I move it? 1 place, 2, 3, and then that 3 counts as my 4th place I moved it. So 10 to the negative 4. Good. All right, again here. 1, 2, 3, 4, 5. So that's going to become 6.273 times 10 to the negative 5th, because it's going to become a smaller number than 6, right? If it becomes a smaller number than 6, it's going to be a negative. Here, though, we have a bigger number becoming smaller. 1, 2, 3, 4, 5, 6. I'm going to stop when I get to a single digit. So 2.1, no need to include the zeros, times 10 to the 1, 2, 3, 4, 5, 6. It's a negative 6, or no, so it's a positive 6, because that is a bigger number than 2.1, right? It's a negative 5 because it's a smaller number than 6.2. All right, again, here's the decimal point. I'm going to move it 2 places. So this becomes 6.71667 times 10 to the positive 2nd, because that number is smaller than that number. Again, we're going to move it 2, so that becomes 5.185 times 10 squared. Good. Now we're going to work on going backwards. So this is going to become a bigger number, because 10 to the 4th, if you put that into your calculator, is a bigger number, whereas 10 to the negative 4th is a smaller number. So we have 6, let's write it out here, 6.91. I want to move it 4 places forward. 1, it counts for the 9, 2, 3, 4. My decimal point is going to end there, so I'm going to add 2 zeros. So that number is going to become 69100. Good. This one is a negative 4, so I'm going to have 1.16. Then I'm going to move it to the left, because this number is going to get smaller. 1, 2, 3, 4. All of these empty spots, I need to add zeros just like I did up here. And then a 0 in front of the decimal. So that becomes 0.000116. Good. Negative 6 again means we're going to move 6 positions. 1, 2, 3, 4, 5, 6. All of these become their own zeros. So that is now 0. Good. All right, I'm not going to do number 12. I'm going to save you the time, but you can do it, and all of the answers are at the end of this. Don't worry. Okay, the next thing we're going to work on is operations involving scientific notation. So you can multiply or divide the coefficient and then multiply and divide the exponent half using the rules of exponents. That's what I like to do. So here we separate 6 times 10 to the negative 4th divided by 3.2 times 10 to 10 squared. We separate it into 6 divided by, right? A fraction means divided by. 6 divided by 3.2 time, and multiply that fraction by 10 to the negative 4th times 10 squared. So what that's going to look like is two different things. 6 divided by 3.2, which becomes, I would just put that in my calculator, 1.875. That decimal ends good. 1.875. That's the blue, right? So that becomes 1.875. And then we have 10 to the negative fourth divided by 10 to the second. We're going to talk about it on the next page, but the rule for exponents is if you have the same base of 10, and you're dividing the bases, you can subtract the exponent. So 10 to the negative fourth power divided by 10 squared becomes that same base, and then you take that top exponent and you subtract the bottom exponent. Negative 4 minus 2 is 10 to the negative 6. So we have 1.875. We're going to keep that multiplication symbol. And then that second term is 10 to the negative 6. Okay, that I find to be the fastest way to evaluate those expressions. You can also do it the long way where you take this, change it to an exponent. Or sorry, that's absolutely not what we're doing. Change it to a longer decimal, a long form, change this one to a longer whole number, and then divide those, and then look at what answer you have, and convert that back to scientific notation. So you can convert out of scientific notation, do the work in your calculator, convert back into scientific notation, or you can work each side individually and put the multiplication between them. Good? Either way, you get 1.875 times 10 to the negative 6. Sorry, I'm using the dot and the multiplication symbol interchangeably. I like the dot, but they like the multiplication symbol. All right, let's do this one. 7 times 10 to the third times 3 times 10 to the fourth. So separating coefficients from the bases. Just like here it was 6 divided by 3.2, here it is 7 times 3 becomes 21. And then 10 to the third times 10 to the fourth. The rule for exponents here, when you're dividing them, you subtract. When you're multiplying them, you add, because that becomes 10 is the same base, 3 plus 4 is 10 to the 7th, is how we got that. So now that becomes 21 times 10 to the 7th. We've added a note that that is still wrong. Why is that wrong? Pause the video. Tell me why. Correct. You are correct in what you said. 21 times 10 to the 7th is not in the correct form for scientific notation. We need to move the decimal point from here to here. So we have 2.1 times 10 to the first times 10 to the 7th. We're going to combine the first and the 7th, and we're going to get 2.1 times 10 to the 8th power. Good? All right. 8 times 10 to the 4th divided by 4 times 10 to the 8th. Just going to divide it. 8 divided by 4 becomes 2. 10 to the 4th divided by 10 to the 8th becomes 10 to the power of 4 minus 8, which is 10 to the negative 4th. So we have 2 times 10 to the negative 4th as our final answer there. Here, same thing, but we're multiplying. Take the coefficient, 5.8 and 4.2, and then take the exponent, 10 to the 4th and 10 to the negative 2. 5.8 times 4.2 will give us 24.36. And then, sorry, we don't need a calculator anymore. 10 to the 4th times 10 to the negative 2nd is 10. 4 minus 2 is 2. 24.36 becomes 2.436 to the times 10 to the power of 1 times 10 to the power of 2. Negative 2, sorry. No, 4. Yeah, positive 2. So that is 2.436 times 10 to the 3rd. Good? Okay. Evaluating algebraic expressions is just we're following order of operations. Remember that absolute value symbol, the radical, parentheses, and brackets are all grouping symbols. Good. The division bar is also a grouping symbol. So we want to solve 7x minus 4y and x plus 13 before we divide that by that. Good. So 7x minus 4y is just going to be 7. X is 7. So 7 times 7 minus 4 times y, 4 times 10 over 7 plus 13. So that's 49 minus 40 over 20, which just becomes 9 over 20. Leave it like that. Good. Absolute value bars, that means distance, okay? What is the distance between -5 and 7? Absolute value, x is -5, y is a positive 7. So when you take -5 and you subtract 7, it's kind of like adding 5 and 7 and getting 12, right? But they're both negative, so it's the absolute value of -12. When you take it out of absolute value bars, it's now positive because absolute value is distance from 0. If you look at a number line, here's -12, here's 12, here's 0. This distance is 12, just as this distance is 12. So think of the absolute value as your distance. -12 is 12 units from 0 on the number line. All right, here we've got, just going to change the font so we don't get confused. Or not font, I wish. Color. Absolute value of x means the absolute value of -8 minus the absolute value of y, which is 4. So we have the absolute value of -8 is 8. The absolute value of 4 remains 4. So 8 minus 4 is a positive 4. Good. Absolute value of 6x minus 4y, 6 times 4 minus 7 times 6 is, 6 times 4 is 24. 7 times 6 is 42. Absolute value of 24 minus 42, -18. And again, pause the video, try it yourself, and then check to see that I got you the right answer. If you already know this, you're welcome to fast forward the video. You don't need to take any notes that you don't need to take. You don't need to watch any concept that you can get through it on my math lab. You don't need to watch the content. Good. Here we're just going to put in the absolute value of 2. Here we're going to put in the absolute value of -5, and we're going to multiply them, okay? And remember, at the end, you have the answers. So 23, you can find the answer down here, okay? Make sure you're right. Then we're going to evaluate exponential expressions. What is the base of your exponential expression? There's a difference between -3 squared and the parenthesis around the -3 squared. Good. All right, so -3 squared, 3 squared just means 3 times 3, right? So that becomes that, but -3 inside the parentheses means it's a -3 times a -3, so that gives us a +9, right? Here, we just have 4x squared. When it's within the parentheses, we have 4 squared x squared, which is 16x squared. So just make sure you see the difference between all of that. The rules of exponents, let's just go through them quickly. If your base is the same and you have exponents and you're combining them through multiplication, you keep the base, add the exponents. Okay, and these are just rules. You can Google these. These are just things to know about exponents. If you're taking an exponent and raising it to another exponent, you want to multiply those. So a times b. Again, we're just using that same rule, but we're distributing it to the a and to the b. So here we have x, a times n times y, b times n. Good. Anything to the 0 power is 1. Doesn't matter how complex it is. If you raise it to 0, it's going to equal 1. Good. We already saw this when we were doing scientific, but basically if the base is the same, you subtract the exponents for division. Similar to when they are multiplied, you add them. When they're divided, you subtract them to get in the right order. This, you always have to end with a positive exponent, okay? So if your exponent is negative, move your base and exponent across the fraction bar to make it positive. This is a negative. It's now in the numerator. If you move it down to the denominator, that exponent becomes positive. Okay, let me show you. So here we were doing 3 to the power of -2, looks like that. 1 divided by 3 to the power of regular 2 is that same number, okay? So it's just a rule. I put a 1 down here because dividing by 1 doesn't change the value of a number, okay? So if you need to make it a fraction so you can move it across the fraction, you just put it over 1. If there's nothing on the top, don't put a 0, put a 1, okay? Because if I said this, and then I said, okay, I need to move that to the bottom, I can't say 0 divided by 3 to the power of 2, right? Because that's just going to give me 0. I can say 1 divided by 3 to the power of 2. It's a placeholder when we're doing division. If you put in a 0, it's going to turn everything to 0. Same with if you have 9 divided by 1 is 9. 9 divided by 0 is definitely not going to be 9, okay? It's going to be a mistake. Similarly, if you already have a negative exponent, you can, or sorry, on the bottom, you can move that to the top and it becomes positive. Good. These I'm just going to switch the order. I'm going to go to this one first. So basically, this is the root or the index, and this is the, I want to say radicand. I don't want to say the wrong word. Hold on. It's basically the radicand. It's the power of the radicand. So we'll just say power. There's the root, and then there's the power or the exponent, right? And what happens is when we convert this to just exponent, it becomes that the power goes on top, the root goes on the bottom. So the nth root of a to the power of x is the same as, or sorry, the nth power of x to the power of a becomes x to the power of a divided by n. Okay, that will not come up in today's lesson or like in the homework or anything, but it's good to know to start to become familiar with, okay? So just like we said, n, the nth root of x to the a is x to a over n, just use that same formula, okay? But this x is just being raised to the first power, so we're gonna call it x to the power of 1 over n. For example, the second root of 4 is 4 to the power of 1/2. Okay, because there was a 1 here, understood 1 here. That goes on top, the 2 goes on the bottom. Down here, maybe it's the third root of it doesn't need to make sense. 7 squared, right? Just to translate that, that means 7 to the power of 2/3. All right, try simplifying those expressions without a calculator and then check them with your calculator. 3 to the power of -2, we're gonna move that across the fraction bar. It's gonna be a 1 on top, 3 squared on the bottom, and we know that 3 times 3, 3 squared is just 3 times 3, 3 times 3 is 9. -2 to the power of -4 is what that's supposed to be. -2 to the -4th power means it's 1 over -2 to the 4th, which means there are 4 -2's being multiplied, right? -3 to the -4th is just going to be 1 over -3 to the +4th. Good. Keep going though in your calculator. So -2 to the negative fourth is also, what's negative 2 to the fourth? 16. So that's also 1 over 16, right? And you can check that. It matches that. Good, same here. 1 divided by negative 3 to the fourth. What's negative 3 to the fourth? 1 divided by 81. Is that the same as negative 3 to the negative fourth? It is. Good. All right. Here we're just going to combine. We have the same base. So we're going to say negative 9 plus 7, which is negative 2. We cannot leave it as a negative exponent, so we're going to move it to the bottom of the fraction bar. 4 squared. Oh no, which is 16. Another 116. 5 to the power of negative 3 to the power of negative 1. We're going to multiply those. Negative 3 times negative 1. Negative times a negative is just a positive. 5 to the third is 125 because it's 5 times 5 times 5. Good. All right, here we're going to say 10 to the negative 2, x 3 times negative 2. That becomes 10 squared on the bottom, right? So that it becomes positive. X to the negative 6. I'm just adding a step for clarity. Now I need the x to the negative 6 to move to the bottom too. There's nothing on the top, so I'm going to add a 1. 10 squared is 100. So it's 1 over 100 times x to the 6th, because 10 squared is 100, x to the third squared is 6. It was a negative 2, so it all had to go over the fraction, under the fraction. Over the fraction, under the fraction. All right. Here we are going to, just like we were doing with those exponents, or sorry, with the scientific notation, separate them. So we have x negative 3 minus 3, right? Because we're keeping the base, subtracting the exponents, so that's x to the negative 6th. Y 3 minus 9 is y to the negative 6th as well. So we have x to the negative 6, y to the negative 6. We want them to be positive, so we're just going to call it, 1 over x to the 6th, y to the 6th. Good. Here we're going to distribute the negative 2. Okay. See what answer you get. Check your answer. Here we're going to substitute in the negative 2 here and a negative 2 again here. There are many ways to solve it, but see if you get the same answer. Okay. Moving on to simplifying the square roots without a calculator. What you want to do to begin with is list perfect squares. Okay. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So these are called perfect squares. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81, right? Now, 72 is not a perfect square, right? You want to start at a number below 72 and start dividing. So 72 divided by 64, I don't think it's going to go into 64, right? 49, 36, ooh, it's 36. So the square root of 72 becomes the square root of 36 times 2. The square root of 36 we know is 6, right? And then 2 is still under the square root, and they are being multiplied. So 72 becomes 6 square root 2. You can try to start at the beginning, the other side of the list. 4 is a perfect square, so that becomes 2 to the 18th, but the problem is that 18 still contains the perfect square of 9, so the 18 is going to become 9 times 2, the square root of 9 becomes a 3. That's still a 2, and that 3 has to be multiplied by that 2, so you still get the 6 squared. So you can go from smaller number to bigger number. You just might add an extra step of doing it again. 112, same thing. 112 divided by 64. 112 divided by 49. It's not gonna be 25. 16, 7. Good. So that becomes 16 times 7. So the square root of 16 is 4, so it's 4 square root of 7. Oh, I'm sorry, you couldn't see any of that. 112 is 16 times 7. Square root of 16 is 4, square root of 7. The square root of 6 has no perfect square, so we call it prime. It cannot be factored any further. Good. 18, we already saw it here. 18 is 9 times 2, and the square root of 9 becomes 3, so it's 3 square root 2. Okay. When you get to the third root, it's a little bit different because now instead of using the list of perfect squares, you want the list of perfect cubes. 2 cubed is 8. 3 cubed is 27. 4 cubed is, well, I guess it doesn't matter. 64, because we're looking for 32. So our only hope is that 32 is divisible by 8. And it is. So the third root of 32 is also the third root of 8 times 4. The third root of 8 is 2. So that will look like that. Good. If you have a negative under the radical, unless you're using imaginary numbers, we just say no solution, not real answer. Good. So just substitute the 5 in here, the 5 in here, see what you get. Okay, find the value of the expression using the given values. I'll do this one. So here x is -4, y is 3. So we have the square root of -4 squared plus 3 squared. -4 squared is 16. 3 squared is 9. 16 plus 9 is 15. Can I take 15 and divide it by any of these? I cannot. So we're just going to call that the square root of 15. Y to the power of x is just 3 to the power of -3, which is 1 over the power of, or sorry, 3 to the power of 3, which is 1 over 27. Good. Use radical notation to write the expression. All right. So remember, radical expression said that x to the power of a over b looks like that root of x to the a. Good. So in this case, a is 1, b is 2, x is 16, and we just replace them. So it was 16 1/2. Now it becomes the square root of 16 to the first power, which is, square root of 16 is 4. All right, for 45 and 46, see if you get the same answer that is given at the end. Now we're going to talk about graphing an inequality on a number line and writing in interval notation. All right, so if you have x is less than, x is greater than, x is less than or equal to, x is greater than or equal to, I'm going to just show you what they will look like, all right, on a number line. X is greater than or equal to is going to look like this, okay? Because greater than uses a bracket. or sorry, greater than without the equals to uses parentheses. Greater than or equal to uses a bracket, okay? And since it's greater than, in both cases, the arrow is going to be headed to the right. So the bracket is going to be facing the right or opening, okay? Opening to the right. Now, for less than without the equal to, it's going to be a closed parentheses or a parentheses opening into the other direction and an arrow in the other direction. And then this one is going to be a bracket with an arrow in that direction. Good? So that's what you're thinking with how to describe it on a number line. So here it's x is less than or equal to -4. Here is -4. It's a less than or equal to, so it's going to be a bracket there. And it's going to go forever in that direction. Good. X is greater than -4. There's no equal to, so it's just going to be a parenthesis. And it's going to open in the positive direction. X is, I like to rewrite these so the X is always on the same side, so I'm going to flip it. -6 is less than or equal to X, also means X is greater than or equal to -6. Easier to read that way when the X is always on the left. All right, so now it looks like that one, but it's going to be a bracket starting at -6, and it's going to open towards greater than. Good. X is now, there are two parts, right? We have X is less than or equal to 7, and X is greater than or equal to 3. X is less than or equal to 7. X is greater than or equal to 3. Good. Here, try it, see what answer you get. Graph the set of numbers giving an interval notation. So this I just look at the same way I look at the brackets. So that is a bracket at 1. So I'm going to write down a bracket at 1. And it's going forever in the positive direction. Towards positive infinity is what that means. Infinity always gets a bracket or a parentheses, never a bracket. So this is going from negative infinity, so I know the arrow is going to go like that, to -2. And then if it's a bracket, use a bracket. If it's parentheses, use a parentheses. -7 to -3. Sorry, I've been talking too much today and I've lost my voice. All right. It says, so this is interval notation. Here it says write them in interval notation. So here we went from interval notation to a graph. So now let's go from a graph to interval notation. This arrow in this direction means negative infinity. And then it stops, this one stops at -2, this one stops at -4, but with a bracket. So I'm going to write a bracket. That one stopped with parentheses, so we wrote a parentheses. X is greater than 4. So if it's an arrow going that way, I know it's a infinity symbol. The infinity always gets parentheses. 4. The 4 has parentheses, so I'm going to give it a parentheses. Here we have, again, to positive infinity, and then a bracket at -6. Apologize. All right, here, bracket at 3, comma, bracket at 7. Good. Here we have X is greater than or equal to 1. Here we have X is less than to -2. Here we have X is greater than -7 and less than or equal to -3. All right, last concept we're going to cover in this video is domain of an expression. A definition of domain in college algebra is what gives the value of X a valid output, or what value of X gives us a valid Y. Good. If you're looking at a graph, how far left does the graph go? How far right does the graph go? Are there any gaps in the graph? Okay. The domain is all real numbers if you just have an equation, an expression, a function, but you have to exclude anything that doesn't work. The two things that don't work are division by zero. So you care if there's a denominator, okay, division by zero. The other thing, division by zero, division by zero, division by zero could be, right? The other thing you want to avoid is, now that's another division by zero. Division by zero, okay? The other thing you want to avoid is taking the square root of a negative number, okay? Here we have square root. We don't want that to be negative. We don't want that to be negative. If you don't have any variables in your denominator, numerator, denominator, no variables in your denominator, no variables under a radical, you just say all real numbers, okay? But we can't say that because we see that there is an x under, sorry, in the denominator. Okay, that's called a rational function because it's a fraction. So what you want to do, you can ignore the numerator. We don't care if there's a variable in the numerator. You want to take the denominator, set it equal to 0. So in this case, the denominator is just x. X is 0, solve for x. That's solved, right? The domain is all real numbers except cannot be 0. Okay? Up here, take the denominator, set it equal to 0. Solve for x. So I'll add 4 to both sides. X is 4. So my answer is the domain is x such that x cannot be a positive 4. If it were a positive 4, we would see that that would become 0. It's okay if the top's 0. It's not okay that the bottom's 0. Okay? Here, x plus 6, it looks a lot like x minus 4, so you try that one, see if you get the correct answer. Here we have, remember, you can ignore the top, we're just talking about domain here. This domain is going to be x squared plus 4 is 0. Subtract that 4, you get x squared is negative 4. Now you have a square, so you want to take the square root to cancel out the square, put a plus and a minus beside your answer because there is the real root and or like the primary root and the secondary root. There are two numbers that you can square to get a negative 4. Yeah? Okay, so the square root of x squared is just x, and then plus or minus the square root of negative 4. That is, as we saw, not a real answer. So we can say all real numbers. Will that denominator ever be 0? We know that negative 4 plus 4 would equal 0, right? But can x squared ever equal negative 4? No, it's not possible, right? All right, x squared minus 25. So we're going to take that same x squared, not enough space. That same x squared minus 25 is 0. Add 25 to both sides. X squared is 25, but now we can really do it. Do it for real. So we're going to take the square root of both sides, put a plus or a minus because, so that cancels that, plus or minus the square root of 25. The square root of 25 is 5, right? So we have x is negative 5 and 5 because negative 5 squared will give me 25 and 5 squared will also give me 25. Negative 5 squared equals 25. 5 squared, it's 25. So both of those make this true. The negative 5 and the 5 make this part true, make this part true. Okay. Now, the square root of x plus 8. Good. This cannot be a negative number. That was the rule. So what we're going to say is we're going to take the number under the radical, and we're going to, just like here, we set it equal to 0 because that's what it cannot be. Here we say it is greater than or equal to 0, and then we solve it. So minus 8, x is greater than or equal to negative 8. Okay, as long as we are bigger than 8, negative 8, or negative 8, that will not be a negative. Okay, in interval notation, so we have x greater than or equal to negative 8. That means the equal to means it's a bracket, negative 8, and it can go on to infinity. You can get anything bigger than negative 8. Good. Here we have 3 minus x, so we're going to say 3 minus x is greater than or equal to 0. Subtract 3, negative x greater than or equal to negative 3. Now, you divide by negative 1 or multiply by negative 1. Remember, when you're multiplying by a negative with inequality symbol, you have to flip the inequality symbol. Negative 1 times a negative x makes it a positive x. Negative 3 times a negative 1 makes it a positive 3. So x is less than or equal to 3. That means it can be from negative infinity to 3 with a bracket, and make sure that makes sense. So x can be 3, 3 minus 3 is 0, x can be 2, 3 minus 2 is 1, x can be negative 3, 3 minus negative 3 is a positive 6, so those will all be positive numbers. And we did it. Make sure you look at the back if you have any questions, if any of your answers didn't turn out like my answers. Thank you guys so much. Sorry, this first video is a little bit long. We covered a lot of material, but it will get easier. Thank you again so much.